Okay, this is number 10. You can see the original problem up top. Hopefully this is big enough for you to see it all. Um, what I did from this first line to this second line is I just split this apart into its two binomial factors so you could see how it's made. Hopefully you can see that as one of those perfect square uh, of a minus 5 times a minus 5. Okay, and what I did over here is because they have the same denominator, I put it over a single denominator and I combined these two top numerators. 6 plus a minus 3 is a plus 3. Okay, and you can put it all over the same denominator. So what do we need to do now? Well, we need to have this denominator have the same denominator as this. So since this is a minus 5 times a minus 5, we have to have this as a times a minus 5, and we have to do it top and bottom. So I multiplied top and bottom by a minus 5. And I also put this back together. I just split it apart so you could see what it looks like and know what the factors were. Okay, so we do that times that, that times that, and that results in this right here. Okay, now that they're over the same denominator of a squared minus 10a plus 25, we really are just left with, we can just treat this numerator set as the new problem. Why can we do that? And I did it here to show you, but I might not do it on every single one. I might just jump to the next line. Is these cancel out. If you multiply by what the denominator is, that cancels out there and there, that cancels out there and there, leaving you just with a squared minus 4a minus 12 equals a squared minus 2a minus 15. Okay, and that's what you get right there. Okay, so from there, what do we have to do? Well, we've got to, and I'm going to move this over. It's going to overlap with what I have down there, but we've already dealt with that. So what do we got here? Okay, well, we've now got what we had here on the bottom. I put it up top, and what I'm doing is I'm subtracting the a squared away from both sides. Okay, you can see that. They both have a squared on them, so we get rid of that term. We're left with this, negative 4a 12 equals negative 2a minus 15. And now I'm going to add 4a to both sides because what I want to do is I want to eliminate that there. Okay, and then I'll simplify. We've got just the negative 12 left over, and these two go together to be a positive 2a minus the 15. Now that I just have the a term here, I'm going to undo this constant term over here by adding 15 to both sides. Okay, then when I simplify that, I get 3 equals 2a, and now I've got to just divide by the coefficient to get down to a single a. And when we do that, dividing by 2, you get as an answer 3/2 equals a. And that is the solution to this problem.